Today I am going to be talking about the physics behind airbags. It takes zero point 0.7 seconds for an average person to react during a car crash. The average time before a person's head hits the steering wheel is zero point 0.5 seconds. To combat potential life threatening injuries, airbags were created. Airbags have prevented over 50,000 deaths in the last 30 years. The first airbags were created in 1953 by John Hetrick. It was first advertised as a safety cushion assembly for automotive vehicles. Hetrick created the first airbag because of a near fatal car crash, including his wife and kids. That very night, he decided to make an object that could stop someone from striking their head on the inside of their car, and thus the airbag was created. However, there was one critical flaw. There was no sensor in the airbags to tell it when to activate. In 1968, Alan Breed created the first airbags that included sensors, and he then proceeded to create Breed Technologies, which proceeded to become one of the world's biggest companies regarding car safety. The first cars to come equipped with airbags was Ford's Mercury Monterey. Ever since, throughout the years, airbags have been used. To look at how airbags help prevent deaths, one must look at the physics behind car crashes, or more specifically, Newton's laws of motion. Everything that has mass and velocity will have kinetic energy. The greater the mass and speed of the vehicle, the greater kinetic energy and momentum it carries. That is okay until one needs to stop suddenly, or until one collides with something. The energy then must be directed elsewhere. Even though automobiles are meant to crumple and absorb impact, their energy poses a significant risk to the driver and passengers. The problem is, even the people in the car will have mass and velocity, and they too are affected by the laws of motion. Seatbelts do not keep the head restrained, so there is a strong possibility that one might have whiplash. The average human head weighs 3 to 6 kilograms, so if a car suddenly stops, the laws of physics state that one's head will keep going and hit the steering wheel or dashboard. This is where airbags come in. Airbags are used in motor vehicles because they can reduce the effect of force experienced by a person during an accident. Airbags extend the time required to stop the momentum of the driver and passenger. During a collision, the motion of the driver and passenger carries them towards the windshield. If they are stopped by a collision with the windshield, it would result in a large force exerted over a short time to bring them to a stop. If instead of hitting the windshield, the driver and passenger hit an airbag, then the time of the impact is increased. Increasing the time of the impact results in a decrease in the force according to the formula. Force equals change in momentum over change in time. Therefore, if time is increased, for a constant change in momentum, the force on the body is reduced. For example, I weigh 65 kilograms. Let's just say that I'm going 60 kilometers an hour and crash. This would mean my momentum is 1083 kilograms times meters per second. If I crash and I had to stop instantly, my momentum would go to zero in a few seconds or less. I would most likely die. If I had an airbag, the chances I had to survive would increase slightly because I'll be hitting a softer surface later. Every car must be able to detect if a crash is happening. To differentiate between a potentially deadly crash or a minor fender bender, cars use the accelerometer to trigger the airbags. Cars have several accelerometers in case one fails. They detect sudden changes in velocity. Usually, there are ball bearings attached to magnets, and in the case of a car crash, the ball bearings come flying free and triggers a switch that activates the airbags. Airbags aren't filled with any random gas. They are filled using a chemical reaction involving sodium azide. Only 130 grams of sodium azide is enough to produce 67 liters of nitrogen. This reaction, however, also produces sodium, which is both dangerous and extremely reactive. To get rid of the sodium metal, potassium nitrate is added so that they react and produce sodium oxide. The sodium oxide then proceeds to react with silicon dioxide to make a substance that is harmless. This gas fills up the airbag, which is usually made of nylon, in under 40 seconds, making it so the average person hits the airbags as soon as it has started deflating. If a person hit an airbag when it is fully inflated, the head would whip backwards, causing serious injuries. Airbags are a great invention, one that has helped save many lives over the past 50 years.